Okay, so we're going forward with the test for Monday. You've had yesterday as a work period. You're going to have today as a review period as well. You've got Saturday. You got Sunday. You got to get your over the idea of you have to have like 3 hours to study the night before a test. Okay? When you're running a marathon, you don't go out and run 20 miles a day before to get ready, right? You do it slowly. And the same thing should be true in all school classes, but especially physics. If you don't run the miles, if you don't do the work ahead of time, you're going to be in trouble, okay? You can't learn it in 3 hours Sunday night. You just can't, okay? So keep that in mind. Okay, so what are the things that I expect you to know? We had definition of what physics is. We talked about some knowledge, some skills, some attitudes. You need to study physics. That was really just sort of to get us started kind of thing, but there's not a lot I can ask questions on this test, so okay, so look back in your notes. Remember, you get a half-page cheat sheet on the test, right? If you didn't know that, you better learn it real quick, right? Take a regular sheet of loose leaf, fold it in half. Do you get more space when you fold it this way?
Yeah. No. I'm kidding.
Okay. Yeah. Either way, half page, anything you want on it, single side. Okay? Single side. You're not fooling anybody, Casey. Under graphs. Okay? We talked about graphs fairly extensively. What kind of things would I expect you to know? I would expect you to know what the independent variable is, what the dependent variable is. Okay, so that's what that means there. Independent and dependent. The dependent variable is the one that you usually measure, right? Usually measure, maybe with a stopwatch or a ruler or something or other. Okay? The independent is the one that you have some control over. You're the one that's changing. You're putting the ball higher up the ramp, or you're picking the 100-gram mass instead of the 300-gram mass, or that kind of thing. Okay? The dependent is the one that usually goes on the Y, and the independent is usually the one that goes on the X. Although in some rare occasions, we flip that just to make the slope make sense. There was a brief discussion about the magic number 3.6, which you really probably should know from grade 10, I'm thinking. And so have that on your cheat sheet, right? If you've got meters per second and you need to go to kilometers per hour, then you need to multiply by 3.6. If you've got kilometers an hour and you need to go to meters per second, then you divide by 3.6. Okay? Any questions up to there? Matthew, and then I'll get to Connor. Yeah, I'll get to that. Yep, good question. Yep, that side, yep. Okay, there's a good chance you're going to see a question where I'm going to give you some data and you're going to make a graph, both on paper and on the computer. So if you weren't involved in the making a graph on the computer Excel thing. Yeah.
Seriously?
Last time I checked, it was 2012, and literacy on computers is a valuable skill. Oh, you don't yet?
Neither do I. I don't at the same time.
If I had a Kleenex box, I'd be handing them out right, left, and right. We'll get on that today. Yeah, well, we'll get to that. Okay, so yes, make a graph. I would also expect you to know the difference between a linear, quadratic, and inverse shape. Linear obviously is a line. Quadratic is the parabola, half a parabola, and inverse is the one that goes down. So the quadratic is the one that goes like this, and the inverse is the one that goes like that. Now, did we spend more time with linear or quadratic or inverse functions?
Quadratic.
Linear. Okay, so the focus of everything else would be on linear, but you should know about the other two and sort of what they look like. Okay, so that's what this little line right here is referring to. So under linear, you need to know how to calculate slope. Rise over run, y2 minus y1, all over x2 minus x1, right? All that good stuff. Okay? Matthew's asking about the meaning of the slope. And yes, that was a major, major thing that I wanted to talk to you about. We had some issues about that on the lab. Some people didn't understand. Okay, even though it was an example from one of the, or it was a situation that was exactly the same as one of the examples. So how do you find the meaning of the slope? Well, you have to look at the y variable, the dependent variable, and divide by the x, right? You can look at the units. For example, if it's in grams per cubic centimeter, what are we measuring? Density.
So we have to know it.
You have to be able to tell me what the meaning of the slope is. Not necessarily density. What are the chances it's going to be density? Probably not, right? I'm checking to see, do you know how to take the y units and divide by the x units, and can you figure out what that quantity is? I'm not going to pull something crazy like you've never heard of, right? But it should be something reasonably familiar to you. Okay? I will expect you to be able to find the slope and y-intercept as well. Okay, the m and the b. Okay, I will expect you to be able to find the slope and the y-intercept. All stuff that I should point out you should have learned in math class already, right? And the slope and y-intercept. Where? It says find.
Oh.
Find slope. Let me see if Smartboard. Yes, look at that. See, it recognized my handwriting. That's pretty cool, eh, Bray? Can you program that for me? That'd be tough to program, wouldn't it? I don't know how that works. FY intercept. It's not FY intercept. It's an and. Yep. Because we did it. It's where it crosses the y-axis, right? Okay, so that was graphing. Anything else with graphing? Oh, yes, and then we spent a considerable amount of time talking about models, laws, and theories, right? So I would expect you to have some knowledge about that. Definition of a model, definition of a law, definition of a theory. DEFN, definition. Definition. Okay? Models, laws, and theories. The law of parsimony. What is the law of parsimony? Do you remember? The simplest one, the one with the fewest sort of assumptions, the fewest the rules and whatnot, right? The simplest one. That was the story about the mathematical horse, right? But back to models, laws, and theories, okay? You should not believe that hypotheses become theories and then they become laws, because we know that is
Rubbish.
Why is it rubbish? Yeah. Is there a relationship between hypotheses and theories?
Yeah.
Certainly, right? Right? Hypotheses, you form them to start with, you make guesses, right? And then as you solidify those guesses, as you gather evidence, you turn it into a theory. But do theories then become laws? No. There is no connection there. Okay? Remember Rick Perry saying, well, it's just a theory. Well, yeah, a theory is a well thought out thought that has a lot of evidence and is generally well accepted in the scientific community. So, yeah, it's pretty much fact. Right?
But it's not law.
Well, but they're different. They're different, right? Laws are simply things that we see happening over and over and over again. It's a regularity. It's a pattern. What goes up comes down. F equals MA. When we see this F, we see this A, and so on. It's a rule. It's a rule.
How are you going to make it?
Yeah, that's going to be tough, isn't it? You'll have to read and interpret and give me back your thoughts. And I'll have to... No, it's probably be a written out answer kind of thing. I'll have to use subjective analysis to decide how much you actually understand. It's not easy. Okay? But do not think that theories become laws. Okay? Now, there's two types of theories, or there's theories that are on what we call a spectrum, right? So there are speculative theories, and speculative theories are what kind? Can you prove a theory?
Yes.
No. Okay? Theories are not proven. Okay? They are not proven. Speculative theory is simply a theory that doesn't have a lot of evidence. It's not generally well accepted, right? It's still sort of in the developmental stage. It may or may not be accepted as fact later on. It may need a lot more work, right? It's still in its infancy. It's like a child growing up. Theories tend to go from speculative to robust, right? Some theories never make it past that infancy stage, right? Unfortunately, that sort of happens with people too, I suppose, right? It's not a nice thought, but speculative theories grow up to become robust theories. And a robust theory simply means what? Generally well accepted. Lots of evidence. People have tried out the experiments. It's pretty much accepted as fact. Right? Okay, that's a robust theory. Can you give me an example of a theory that might be considered still in the speculative, moving to a robust stage? One that's in the news a fair bit these days. Yeah, global climate change, right? There's still a lot of non-believers, speculation. There's still more evidence to be gathered. Generally accepted in the scientific community, but hasn't quite reached the mass. Yeah, I suppose, right. Well, I mean, that's not a theory, that's just a fact, right? But certainly, yeah, well, okay. But certainly some theories that are generally well accepted, and I might be sort of dancing on thin ice here when I say theory of evolution, okay? Has been around for a couple hundred years. Most scientists, you'd be hard-pressed to find a scientist that wouldn't believe it. And certainly most of the general population would believe in some evolution of some type, kind of thing. Okay? So that's sort of the first part. And then the second part was all the vector stuff that I talked about yesterday, right? Which you guys had, right? So all the vector stuff from yesterday. Okay? Any questions? Yep. It probably, although I was going to say it usually doesn't take a full period, but the period's a little bit shorter this year, so yeah, probably almost a full period for many of you, depending on how the computers act.
It's on the